Let's start today very interesting and easy topic if you understand it well. It is simply supported beam subjected to varying load. You can see it is a beam. Uh, the load is varying from 0 to W pi unit length from end A to end B. The reaction at end A is R suffix A and at end B is R suffix B. First you have to determine load on the beam. So what will be the load on the beam? Simply finding the area of this triangle. This is how much? Half into base is how much? L, and this height is how much? W. So this is the load on the beam. Its CG will be how much? It will be L by 3 from the end B lying at some point at here. So CG is at L by 3. Now next we will determine the reaction at A and at B. So for determining reaction at A, taking moment about B equal to 0. So summation of M suffix B equal to 0. So here R suffix A into L, because we are taking moment about B, so R suffix A into L, we are taking clockwise positive and anti-clockwise negative. So this will produce clockwise moment, so it is positive. Now R suffix A into L minus the moment due to this varying load. What will be the moment due to this varying load? This W L by 2, this is the load on the beam, into CG. CG is how much? L by 3, which equal to 0. From there, if you determine R suffix A, it will be WL divided by 6. So this is the reaction at R suffix A, which is WL divided by 6. Now to determine reaction at R suffix B, we can take moment about A equal to 0, or else we can do summation of vertical force equal to 0, which is downward, which force is acting? R suffix A and R suffix B. So R suffix A plus R suffix B, and upward which one is acting? Just total load on the beam. So it will be minus WL divided by, what is the total load on the beam? WL divided by 2. This equal to 0. From there you can determine R suffix B. If you put the value of R suffix A, you will get R suffix B equal to WL divided by 3. Put here R suffix B, which will be how much? WL divided by 3. Let's determine now load at section XX. So what will be the load intensity at this section? See, for L unit load is W, for 1 unit load will be W by L, and for X unit it will be W by L into X. So this is the load intensity at section XX. Now section left side, these, what will be the load on the left hand portion? For finding the load on the left hand portion, we have to find area for it. It is a triangle. Similarly, we will find the area of the triangle. This is how much? Half into base is how much? X unit, and height, that means value of the load at section XX, it is how much? W into X divided by L. So it is WX square divided by 2L. So this is the load on the left hand portion, and CG will be how much? It will be X by 3 from this section. Now we will find shear force. For determining shear force, we have made a section XX here. So shear force will be R suffix A minus that is load on the left hand portion. What is the load on the left hand portion? This is WX square divided by 2L. What is R suffix A? R suffix A is WL divided by 6 minus WX square divided by 2L. Now you see, left up, right down. We know that left up, right down, it is positive shear force, so it will be positive. Now what is variation? It is, this variation is parabolic variation. This variation is parabolic variation. Now what will be the shear force at X equal to 0 and at X equal to L? At X equal to 0, if you put the value, you will get shear force will be WL divided by 6. At X equal to L, if you put the value, so it will be WL divided by 6 minus, put here L, so WL square divided by 2L, that means cancel, so there will be 1 L. If you solve this, 6, so it will be WL minus 3WL, that is minus 2WL divided by 6, so minus WL divided by 3. So at X equal to L, shear force is minus WL divided by 3. Now for plotting this, we have find the shear force at X equal to 0. The total length is L here. So we have find shear force at X equal to 0. And now we'll find shear force at x equal to we have also find shear force at x equal to L. This is how much? WL by 3 minus. So it is minus WL by 3. The value will be going downward. Let the value get downward up to that much. Now for it, and at x equal to 0, what is the shear force here? You see, at x equal to 0, shear force is WL divided by 6. So WL divided by 6 is positive, it will go upward. It is WL divided by 6. Now I have to determine shear force at any midpoint. We don't know at which midpoint shear force will be 0. So let this shear force, we equate it at 0. That means how much? WL divided by 6 minus W x square divided by 12. Let us equate it at equal to 0. Then we can find at what x value this shear force will be 0. This one, if you solve, you will get x square equal to L square divided by 3. That means x equal to L by root under 3, and the value of this will be 0.577 L. So let 0.577 L be up to that much, or L by root 3 be up to that much. So at this point the shear force, let it be 0. So we'll join this by parabolically making it little curve, because the variation is parabolic variation. So it is a shear force diagram for simply supported beam subjected to varying load. Now for determining bending moment for this varying load, we will know M equals to what? You see, M equal to this R suffix A into X. R suffix A into X. This reaction will try to bend the beam sagging moment, so it will be sagging moment positive, so it is positive. And upward, this triangular varying load will try to bend the beam downward, that means hogging bending, and hogging bending will negative, and this bending will be, this one will be W x square divided by 12. This is what? This is the load on the left hand portion. You can see here load on the left hand portion I have written. Load on left hand portion, this is how much? W x square divided by 12, negative, because hogging bending moment it will produce. W x square divided by 12 into CG. CG is how much? This will be x by 3. So if you solve this, put the value of R suffix A. What is the value of R suffix A? R suffix A is WL divided by 6. So WL divided by 6 into x minus WX cube divided by 6L. What kind of variation it is? It is cubic variation. Now if you put x equal to 0 and x equal to L, you can know the bending moment at x equal to 0 will be 0, and at x equal to L also bending moment will be 0. If you put, you can find here. So where will be the maximum moment? We know that where shear force is 0, maximum moment will occur there. Where is the shear force 0? We have seen that shear force is 0, shear force equal to 0, shear force equal to 0, we have seen at x equal to L by root 3. So maximum bending moment will be occurring at x equal to L by root 3. So M max, if you determine here, M max will be how much? WL divided by 6 into x minus WX cube divided by 6L. This is what? This is the moment which we have determined earlier. So if you put x equal to L by root 3 here, let me focus. If you put x equal to L by root 3, you will get here maximum bending moment, this equal to 0.06415 WL square. This is the maximum bending moment. This will be the maximum bending moment if you put at x equal to L by root 3. So maximum bending moment is what? At x equal to L by root 3. Now you can determine bending moment diagram for it. What is the bending moment at x equal to 0? 0. And at x equal to L, this one will be also 0. And at x equal to L by root 3, this one is how much? 0.06415. Let 0.06415 value will be rising up to that much. And how we will join it? By cubic variation. It will be little more curve. So this is the bending moment, it will be positive. Shear force, it is positive, and it is negative. So you can see this is the shear force diagram and this is the bending moment diagram for simply supported beam subjected to varying load. The varying load is varying from 0 to W per unit length from end A to end B. Thank you.